So last lecture we study about the recursive decomposition. We go with the two example. One is related with quick sort, how it will be sorting the element with the help of recursive decomposition. How it will be a flow, how we decide the number of parameter. We observe that one, recursive decomposition. In that we go with that concept related with recursive decomposition. Um, Related with this parameter. Then we go with finding out the minimum number of number in a array, right? That concept we go with the recursive decomposition parameter. Uh, Whenever we go with this concept, the next parameter is exploratory decomposition. It's another second method of recursive decomposition. Uh, so in that method, we used to be a decompose a problem whose underlying computations corresponding to a search of a space for a solution. So we have n number of options to we go with a number of solutions, and that parameter we consider that in that whatever the computations are correspond to search of a space of solution. So how it can be done? We go with that one. So we portion the search space into a smaller part and search each one of these part by concurrently unit the desired solution and found the actual solution of that one. So how the exploratory decomposition will be done? We go with one example, right? That explanation of the exploratory decomposition with the 15 puzzle problem. So there will be a 15 problem. Just look at a desired state. So here we observe that parameter. So in that it is a the 15 puzzle consists of 15 uh, tills number 1 to 15. Just look out 1 to 15 numbers, and one blank tile placed in a 4 by 4 grid. This is a blank. This arrow is indicated with a blank parameter. So I just make a pencil so you can understand. So this blank one, right? So the tills can be moved into a blank position from a position adjusted to it, right? Thus create a blank into a tail's original position. So either here just look out that in second condition either the 7 will be a move upward here, just like that here 7 is moving upward. So this is a blank possibility. So second possibility, it may be a possible the 11 is moving here. Just look out here 11 is moving here. So this position will be a blank. Then it possible suppose the 12 is moving upward, so the this position 12 is moving upward and this will be a blank, right? So we get the number of solution with the number of position variation. So that thing will be a consider. So depending upon the configuration of the grid, up to the 4 move are possible. So we say that 4 solution will be available to complete and go with the solutions. So that is a one of the importance of the exploratory decomposition. So either the number or the tiles will be a move up, down, left, or right. It is a possible to move any one of that one. So that is a concept related with that one. So initial and final configuration of the title are specified. So the object is to be determine any sequence or a sorted sequence of a moves that transfer the initial configuration to the final configuration. So depending upon of movement, there is a number of possibility with the solution, and that solutions comes to the at the end of that. So but each having a capability to get the different solution to execute the problem or whatever the set of concurrency will be a possible or decomposition is a possible with exploratory methods. So that also be a clarify. So just look at is a desired state, whatever the first stage we given. So we try to move 7 here upward. So there will be a blank of this one. So it is a possible way to 11 is moved to that position. Then it is possible 12 is moved to that position. So last position will be moved. So this is a final state of that one. So we have a possibility with a number of things. So that concept also clarify. Just I make it that's one here with one example. Again, I take a pencil so you can understand better way. So just look out this one. This is one of the puzzle will be given and there will be a blank page. So what we say that there will be a possibility. Task 1, it may be a possible the 15s move to the up. So this is one task. Second task, is it possible the 7 is moved to the down? Second way. Third task, it is possible the 10 is moved towards this one. Then fourth task, is it possible the 11 is moved to the here. So first we get the four type of solution. Again, the each task having a multiple solution to get the exact result of that one. So just look out here for this one. It is also having a four possibility. This also having some four possibility. This also having some four possibility. This also having some four possibility. So that will be a call as a exploratory decomposition. We divide this task into a number of subtasks with the help of exploratory. So that way is a possible. So just I explain one of that one. So either the 15 move to the down and another 10 is moving here. Is it possible? Or the 14 is moved to the below 15. So there will be one back. Second possibility, anyone can be a move. So 12 is will be a move. Here is like any one of the possibility will be a possible with that one. So same number of possibility, number of subset, number of position will be available to get the exact solution. So that will be a clarify the exploratory. The meaning of that one will be a clearing with the exploratory decomposition. So that is one of the famous method which can be explain the concept of exploratory decomposition. Just look out here. So either it is possible to move up, down, left, or right. So that is called as the exploratory decomposition. Possibility of getting the solution with a different way. So we get the number of way to be a possible get the final stages. So rather than one solution, we get the number of solution by moving and that parameter. So we say that it is a puzzle is a one of the best example for explaining the exploratory concept related with the decomposition. So first we go with the recursive, find out the parameter related with the recursive decomposition, and then we go with the exploratory decomposition. That is the one problem that in that whatever the problem whose underlying the computational corresponding to a search of a space of solution, right? So we get the this part in a concurrently until the desired solution are found. So we get the number of solutions to get the exact output of the your problem. So that concept will be explained in a exploratory decomposition.